A very warm welcome to all of you, right, to this webinar. Thanks for joining. Just a quick intro about myself, right? I have more than 17 years of experience in the field of analytics, both data science and data engineering. I'm associated with Cognixia now for more than 3 years, and today I will be walking you through this particular webinar. Okay, so just quick beginning before we get into the session, just a quick introduction about the Cognixia. So Cognixia is basically one of the world's leading digital talent transformation company, and then look at it like we have trained more than 150,000 professionals worldwide. There are 7,000 plus industry veterans are associated with as an instructor with us, and uh, and it's a fully owned subsidiary of the Collabora Group. And apart from that, Cognixia is also authorized training partner for various uh, brand like Red Hat, Microsoft, AWS, ITIL, and so on, right? And it also have various awards and accreditations, which you can see on the screen. And they have, we have this center of excellence on various technologies, and trainings are provided all over the world. Like it's a machine learning and AI, microservices, RPA, IoT, BI technologies, DevOps. Almost it covers all the modern technologies which are relevant to the industry today. Okay, so let's quickly get into the agenda for today. So for today's agenda is I will walk you through what is AI and data science. I will also I'll ensure that you at least learn those jargons like what AI, ML, DL, which you often hear about it, right? And I will try to put one example for the motivation perspective. Then we'll go over this machine learning overview. Then I'll show you how the project lifecycle happens for the data science, and what are the tools, technologies are used for machine learning, and why we should be using language of choice is mainly Python. There are various other languages also which we use it for machine learning, but specifically I'll cover like why Python is so popular. Then we'll look into machine learning pipeline, how to build it, and like type of machine learnings overview. uh, and at the end we will cover this deep learning overview and one case study. I will try to walk you through. At least I'll show you on the Jupyter notebook like how it looks like, right? And at the end I'm happy to take the questions and answers. With that, let's get started, right? So evolution and future of machines, right? What uh, we are living in the world of humans and machines, right? So humans have been evolving and learning from their past experience, right, since millions of years. We like since even when you start walking and all, right, being a child, you basically fell multiple times and then basically learn from that, right? So with experience and all, so human learn from the past, learns basically from the past experiences, right? On the other hand, the era of machines and robots have just begun. We can say begun because as compared to the humans, right, you can consider in a way that currently we are living in the primitive age of machines, while the future of machine is enormous and it is beyond our scope of imagination. So in today's world, these machines or robots have been programmed, right, before before they start following your instructions. But what if machine starts learning on their own, from their experience, work like us, like feel like us, if they can get the emotion like us, right? So and start doing things more accurately than us, right? There are many use cases where they do well than human, which is kind of a repetitive thing. But still, just remember, this is just the beginning of the new era, right? We are not yet reached to that place. Okay, but still we have made a lot of improvement in this particular area. So what is artificial intelligence, right? So what is the idea behind that? So this is all started in 1950, right? Hope you heard about the name Alan Turing, right? He was a great mathematician, uh, cryptographer who deciphered the Enigma machine in World War II. And basically, he also laid the foundations of the modern day computer and artificial intelligence. It all started somewhere, as I mentioned, like in 1950. In fact, before that, right? But it all started at that time when his work permeated into wider public knowledge, right? And it gave birth to the idea of general AI, right? What is general AI? Basically, general AI is idea is to mimic the human brain. Okay, but that's what the objective of a thought of Alan Turing. But the answer is is no, right? Because today computer cannot possess the same characteristic of human intelligence, right? Including reasoning, interacting, and thinking like what we do, right? So we are still not at general AI, but we now, but at least we are good at the narrow AI. There's something called narrow artificial intelligence, right? So those technologies which can accomplish a specific task, such as playing a chess. So like computer can play chess very well, right? So like recommending you the Netflix TV show, right? Identifying your spam emails. All of these exhibit parts of human intelligence, right? But how do they work? That's where the artificial intelligence and machine learning comes into the picture. Okay, so you must have heard many times about all these jargons like AI, machine learning, deep learning, right? Data science. So let's see how they what they are basically, right? So I would say you look for this particular circle. This is artificial intelligence, right? Inside artificial, basically artificial intelligence is one umbrella. Inside you have the machine learning, which is the subset of artificial intelligence. So with this, as I said, overall objective of artificial intelligence is to mimic the human brain. Okay, but we started getting some success in 1980s or so, right, with the machine learning, right, where we started spam, like able to segregate the emails and all with spam or ham that way, right? And but later, then recently I think we able to get the success for the deep learning in but again, deep learning is the subset of your machine learning. Okay, so we'll see all of them, right, one by one. And data science is something which I would say that is kind of a is which you use it to solve the business problems, right? And data science utilizes these techniques like artificial intelligence, machine learning, deep learning to solve those business use cases, right? So like what do you see on on this particular screen? I don't know whether you guys are able to put it on chat. Feel free to put it. I'll just give a couple of seconds. What exactly you see here? Maybe I'll just put a hi on chat if you want to put it, you know, there, reply on that. You can do so. What do you see on screen? Okay. I'm sure you must be able to see on the screen a letter M, right? Okay, so you're able to see this letter M on the screen, right? All like with a different, way it is being represented here. And I hope all of you must be able to recognize it. It's all letter M, and I'm also sure you must not have seen all the types of M, right, in the past, right? But still you are able to tell this is M, right? This is called intelligence. Okay, this is called generalization. Basically, you're able to predict or assign a label to the new observation based on the model built from the past, right? Like your brain is having some model, it is built from the past, it learned from the experience, and you're able to generalize the problem, right? And remember, like, you're not storing, right, each and every word in your brain, right? Your brain doesn't do that, right? It must have seen, a couple of letters, but it is able to tell still that it is M. But machine cannot do that. You have to give each and every type of pattern to the machine, and then it learns, and basically it will tell you, like, it is M, right? But up to certain extent it is able to do that, but they can still do the mistakes, right? So the idea here is, what is intelligence, right? Like, so hope you understand that your human brain, the beauty of human brain is that it is able to do the generalization, right? We don't need a big server, right, or cloud somewhere to store each and everything we learned and all, right? But with little we are able to make, we can generalize the problem, and we can, that's called intelligence. So what happens within, before we get into, like, it's all about data, right? And data is exploding all over the internet, right? Data is, what is data, by the way? Data is everything, like what we have written into the, we used to maintain the file and all, like, by using pen and paper, that in the government offices and all, right? That, or whatever form you fill it, all those things are data, right? And apart from that, when you go to the shopping cart, for shopping, for buying a grocery and all, like whenever you do any kind of transactions, that is also generating the data, right? That is also getting stored, right? It goes to, if you're doing the payment, right, via your credit card or debit card, it is also generating the data. Banks are storing that information, providing you the statements at the end, right? So look at it, like how we are generating so much of data, and we are the people also who are, generating the data and giving it to the companies like Google, Facebook, yeah, Twitter, right, YouTube. And it's something we are, generating it and uploading it, we are sharing with the friends, WhatsApp, right? So look at the amount of the data which is, kind of growing, right? And it's and these figures which you see are just a minute, you know 1 minute of internet data which we do there. So look at it, like, 1.3 million video views happens in a minute or so. This might have gone up by the time I've created this particular PPT. So 30 hours of video uploaded in a minute or so, right? So you can see that, how big the data is today. So there are a lot of opportunities for doing the data science and, analytics use cases for each and every industry. In fact, we see the data around, us. In fact, we see the use cases of the machine learning and deep learning around us every day, right? I'll show you some examples, right? I'll walk you through that example to make it more clear. Okay, so how does DS and ML fit with the organization's existing analytics, right? So basically, if you talk about, like, what is data science, it is mainly, a data science is a multidisciplinary field. Okay, there's just a definition, but if you see that data science involves, a lot of things, like knowledge of data, data mining, machine learning, AI, and, databases, processing, visualization, statistics, right? And it's all just a little subset of those. So if I broadly classify, you need to have the knowledge of the statistics or mathematics, right? Basic stats, basic maths is okay. And if like 9th 10th class mathematics. And then you need to have one programming language, which is, language of choice is Python, right, which is very easy to learn. And the third is important part is the business domain knowledge, right? So domain knowledge is also very important when we solve the business problems, using data science, for the data science. So what is the goal of data science? Basically, the goal of data science is to turn data into data products, right? If you think of, companies like Google, Facebook, right? All these companies are mainly, you can say, data companies, right? Amazon, Facebook, Microsoft, and all, like Google, right? They all are data companies, and we are the people who are giving the data to them, right? So let's get into some examples of the data, right? So when you must be using Netflix, right? You must be using Twitter, Facebook. Some of you must be also have seen the YouTube and all, right? So all these recommendations which comes is powered by, like we call it as a recommendation engine. It is something which is developed by using the machine learning and algorithms. Okay, so like the movie you liked, the movies we think you will love, right? All these kind of things which comes, it's a kind of a recommendation based on your past experiences. It will start showing you accordingly, right? Similarly, in the Twitter, you will say that who to follow, right? And like depending, like if you are following one politician, it will start showing you like, maybe you may want to follow this politician also. And if you follow kind of a one friend, right, and your friend is also following some other friend, right, they will try to somewhere find the common friend, and they will also suggest you can also follow so and so person, right? Even with the LinkedIn also, they provide. So this recommendation is very successful uh, machine learning problem today, which you will see very often, like even in the Amazon website and all, like when you're putting some order, right? Uh, if you are buying a laptop, it will show that like people who buy laptop, they also buy the bag, right? So they will try to sell you the laptop and bag together, or with some other accessories of the computer. And this is like YouTube, right? Like autoplay, right? Depending on what you watched in the past, YouTube will start playing the recommended one automatically for you. Another use case in the data science which you can think of is the healthcare, right? Today we wear the smart watches and all, right? It basically captures each and every activity of you, like running, walking. Like we all want to see like how fit we are, right? And we try to maintain that way. So that data is also today it is being used to identify, to predict any kind of disease which can happen, right? So this data is, so look at the data is so powerful today, right? So what, like predicting health issues like heart attack, diabetes, BP, etc., is all possible, right? If the amount of activity which we do, there are some apps which allows you to put the amount of water you drink in a day, what you eat and all. If we start putting all this information, it can become a more accurate information. It can start providing you, right? So even like you can do this we can do the survival rate of the some of the diseases like cancer and all, right? And like in what stage person can survive for how many days and all, and it is pretty much accurate nowadays, because look at how many uh, because there's a lot of data, right? And then that past information can be used to come up with the survival rate of that. And also it is being heavily used for the drug discovery and all, right? And so these are some limit, some few use cases in the health industry. So I'm just showing you in the different industry, you know what all things use cases could be. So there's another example in agriculture, right? And in fact this is something which is live. Many startups are actually doing it in this particular field, right? And they have some smart IoT devices which is there in the field. Okay, it basically sending the sensors, so those are sensors are there in the IoT, and those are sending the signals to the they're sending the data, right, somewhere in the cloud. And then analysts are basically doing the analysis on that, and saying that how much amount of pest control to be applied depending on the insects and all. Okay, and it's something which can be done just and by sitting on the laptop, and you have the data and you're doing the analytics, and they're able to generate that report and provide it to the farmers, how much what you can do, right? Analysis of the field, like agriculture land, and what they can do to improve it, right? And then you have multiple use cases of the you know cars, like automated self-driving autopilot cars are there. Connected cars is a feature where car can talk to each other. And even like car, like let's say if every year you need to send your car for the servicing, right? It will basically show you on the dashboard whether do you want to schedule an appointment. uh, do you want to schedule an appointment with for the servicing? And if you say yes, there are around 32 to some sensors are there in the car. Okay, it basically, the moment you say yes, it gets triggered, and it packages all those signals into one message and send it to the service center. Okay, and the service center person can basically look at the it's basically a diagnostic data, right? They can see that what is the, is there any warning lamp which they can look into it, right? And they can basically suggest you before your car can come to the service center. They can suggest you, it's better you get uh, brake oiling done, or maybe you need to fix you need to change the AC filters and all. So all those things are possible with this connected cars and all. And by the way, all these things are live. Like it is something Volvo Cars implemented it sometime in 6 to 7 years back. I worked for one of their project for the connected cars, so I know it well. Okay, coming to this one, like data science applications, banking, and so in the banking domain also, like like this fraud detection and credit risk modeling, like loan defaulter, credit card defaulters. Like when we apply for loan, right? Like so bank will look at the multiple factors. They will ask you the data, and there is a credit score for all of us. Okay, so uh, they will basically that CRISIL one who maintains that, right? They will look at it, and accordingly basically they will give you the loan. Okay, they will assess that whether you would be able to repay the loan or not, right? Who is likely to be get defaulted, right? So those things can be done, and any kind of fraud detection is happening. Like maybe if you have the credit card, and it, or you have some buying pattern. Okay, and maybe every week we go for the shopping, like grocery store and all. Okay, all of a sudden if there is some different pattern is coming in, huge amount of some transaction happened, or maybe it is out of city, different city, or it has happened some in international, right? So that is something kind of one I'm just trying to tell you is an example for the fraud detection. So they try to find it out anomaly, right, in the transaction, and then they will alert you. So you might see the messages like if it is this is the transaction happened, if it is not you, please contact us immediately, kind of, right? So then another in the telecom sector also, like, and it's not limited to telecom sector, like churning customer, right? So how you can stop your customer before they can leave you, right? So that's the whole idea to how we can stop our customer, churning customer, right? And that's where we do the personalization, right? Like let's say all of a sudden you see that, okay, people are started changing, right? Like if someone is using like a Reliance Telecom, right? And they tomorrow switching to the Vodafone, or maybe it's a vice versa, which happened in India, right? All of a sudden. So so that's something is like industry, like telecom industry started looking into it, their data, like how many like what is the reason why people are basically moving away, right? So this could be is it a poor service we are providing, so they will is they need to look into the data which is there with the service center, right? If people called, so they need to identify why customer is leaving us. Okay, and some of the interesting thing came up, like if friend is leaving, then other friend is also leaving. That happens at the at the young age. So how can you, once you identify who are the potential customer who can leave me, right? Then you need to kind of start giving them some sort of offer to to retain them. So that's what all about the this churn analytics. So it is not just limited to the telecom. This is something which you do it in every industry, right? And then chatbot season start, like this is something which is you might have seen, like Siri, Amazon Echo, right? Cortana in Windows and all, right? So all these are mainly, right, are the use cases of artificial intelligence, right? And rather it's all deep learning. Okay, so coming back here, like like let's take one motivating example which I said. So this is a story of like Kenya, and sector is dairy farm. In 2000, somewhere in 2011, right? There were mainly three types of mainly one problem, that is uncertain yields from cattle, right? Cattle assets, both in milk and money, right? And these were the three main reasons, like cattle gestation and on, which basically affect the milk yield. Okay, cattle feed, like quantity, quality, and disease, and then volatile market prices. Okay, so and the another problem is like Kenya is like like okay you and it's also vast, it's a dispersed. Okay, farmers are small and dispersed over vast area, and similarly they have a city, and then maybe villages are very far and all, right? So it was not very well connected that time. And so but one thing was good, that there was a like mobile usage was high. At least people were having that button phones and all at that time, right, in 2011. So that this was the silver lining, right, for the Kenya. And then there's one lady called Sue Kawumbu. Okay, she entered here, and she started a iCow subscription based info services. So who is Sue Kawumbu? She's basically like a fourth daughter of one of the farmer in one of the village. And she went to for she did, I think she was the first graduate in her uh, home or village. And she did the analytics course in the from Oxford. She had opportunity to stay back in UK, but she decided to do something for coming back and do something, right, and in Kenya itself for the farmers. So she came back, and she started like anyway she had the domain knowledge, right? And of this, because being from the farmer family, so she started collecting the like she had the domain knowledge, right? So she came up with the idea called iCow. Okay, send me three problems in a prescribed format in the mobile, and I will get back to you with the answer. That will basically help to increase the yield of the milk. Okay, so that was the whole idea, right? And she also gave the TED talk on and so this is how it basically looks like in the mobile phone, right? You basically send the name, age of the cow, and what like send the details about it, and you basically send three issues in particular format, right? And she basically she will respond back. And this is something which she started completely free. Okay, and 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 like within few months, maybe 7 months or so, almost 42,000 signups happened. In fact, it's now you can say that very well all the farmers are connected to the to iCow. So think about it, like how she might have done it, right? Maybe when she started she didn't have the data, right? But at least she had the domain knowledge about it. She just started, maybe started using her domain knowledge, and then she started sending the information. But look at the amount of people started signing up and all. Slowly, definitely it might have started slowly, right? They are sending the information about the farmer. She's having all those data is being collected, so data is so rich. She has the complete data about the farming related for all over the Kenya, right? And look at the power of the data, right? And so if she's doing free, right, how she would survive, right? Like, so definitely there is a byproduct of it, right? So as a byproduct, iCog became the most reliable database for non-farm businesses, right? Like veterinary doctors, she started connecting, veterinary doctors started connecting to her. she's connecting with the farmers. So farmer started using her platform for taking that kind of help also. Even the NGOs and government agencies, they didn't have the they don't have that much reach data which she is having. If government want to do some sort of policy, and for the farmers and all, if they want to reach out to them, she's the one, right? There was no competitor for her because she's having the like the most reliable database with her. So all these things started with the social, but this is the byproduct of the data. So data is so powerful, right? Okay, so what is then? So what is this machine learning about it? But by the way, she all these things she's able slowly able to do it, utilizing the analytics, right, in order to help them, right, to do the prediction how much ill could happen if we act in this way, what can happen, right? So she might have started with the Excel sheet and all, but then slowly she must have grown her the data and all, right? Database. Okay, so what is machine learning? So we just seen in the beginning that machine learning is a subset of artificial intelligence, right? Which provides you, which you can just think of like machine learning. Basically, you machine is learning by itself, right? It's the ability of machine to learn by themselves. That's what the machine learning is. So it requires a data, past data, which you need to feed it, right? And it will automatically learn and it will predict the future, right? So that's what the machine learning is. So what is what are the tools and technologies for machine learning today, which people use it? So these are some, name a few of them, which is quite famous. That is Python, R, SAS, right? And Python is like one of the preferred language which among the data scientists which they use it. And the one of the reason is also like it has a big community, right, which is continuously helping to improve it, come up with the big machine learning libraries all over the world. It is open source, freely available. You can also contribute to that, right, once you learn it. So and Python is basically easy to learn, right? And so that becomes a obvious choice for the Python. And Python is also robust, scalable, right, when you run it into the production and all. So Python became a very obvious choice, and it is very famous even in the scientific community, right, for doing the statistics and all. R was basically very famous for the, and in fact today also people use it for statistics and all. But Python basically slowly caught up on the statistics perspective as well. And it provides a lot of visualization tools as well, which you can use it. So and it also provides you opportunity to integrate with other languages also. Whatever you have written in Java language or C++, Python can basically integrate that, or it can call those programs also, right? So what you could write by using the C++, Java in tens or 100 line of code, those can be achieved in couple of lines of code in Python. So it is so powerful. So who is using Python? So Python, as I said, like it's a kind of a language of choice today. So everyone is using Python today, right? All the industry is using. So these are the some of the top brand who is using Python today. And extensively they are using it. So Python is famous for doing the web development today. Python is famous for doing the automation, for machine learning perspective, deep learning, right? So Python is being used for it's a language of choice today. So I just said it's a simple, easy to learn, right? Open source. It is high level language, right? You don't have to much bother about the low level details about memory allocation and all, right? It's a portable. It means it's a platform independent. You can run Python. If you created a program in Windows operating system, you can run it in any other operating system, right? It supports different programming paradigms, like you can do object oriented, procedure oriented programming. It supports that, right? And as I said, it's kind of extendable, right? You can invoke C++ libraries and all also. Yeah, so we just talked about, right, like it's robust for productivity. It increases the productivity because you just have to write, like few lines of code to achieve something. And a lot of libraries, extensively library supports are available, which you can on the fly just import it and use it. So someone has written the libraries to achieve the things, and you can easily, it is available on internet, and you can basically you plug and play and use it. And you can in fact create your own and also uh, support that community by, so it is also free. Like you can if you want to help in that community, Python community, you can also do so. Okay, so coming to this, like data analysis and categories. So before we get into the machine learning, I'll just want to cover one more thing here. uh, Data could be of multiple types, right? We deal with it like structured data or unstructured data, right? The structured data, something which you can think of, which is having a label, right? Like in Excel sheet, when you write like name, address, columns, which you put it, that's kind of a structured data, right? Which is there in the tabular format, which you can store into the relational database systems, right? But then we have a unstructured data, which you've seen that internet minute, which we generate, like this images, videos, text files, right? And text files with like maybe they may not be the proper delimited and all, JSON data, right? So it can be so you see the challenges, like structured and unstructured data are there, right? So few years back there was a challenge, like where to store that data, but that problem is gone. Today we have plenty of space. It's a cheap database, is cheap, you get the this space, HDD, SSD, the cheap space is there. Like even the space is increasing in our computers and all, right? Even memory, even nowadays your mobile phone can have in GBs, right? Like so so that way data problem, storing them is gone, but the new challenge is how to analyze them, right? So that's where the machine learning and deep learning help to analyze the data, to utilize that data, and come up with nice patterns about it, and solve the business problems, right? So each and every industry is using today, right? Analytics is the basic need for the industry. Okay, so these are, you can divide analytics in three. So descriptive analytics, predictive analytics, and prescriptive analytics. So descriptive analytics is mainly what has happened, right? So let's say if you have some sales related data, you may want to see that, okay, what has happened, right? Okay, by looking at the data, it will tell you the what has happened so far. Like, okay, we have the profit this much, we have lost this much in so and so particular product, in particular department and all. That kind of information is something which we call it as a descriptive analytics, right? And prescriptive analytics is what should we do. Okay, if we do the should we do the advertisement, should we do the marketing here, right, to improve the sale, right? So that's something from your analytics. You are basically finding what action should we take now, right? And prescriptive and predictive analytics is what could happen. You can forecast, like, okay, if this is the pace you know of my business, like profit or loss, then if it is, if I'm making a loss continuously, like how much, if this pace, if I'll go, how long I can survive in the market, right? The company can take the decision whether I should just stop this particular product, right, if I'm making so much of loss. And if I'm making, or other way around, if it is something profit, I'm getting only making a profit of 10%, how can I go from 10 to 15%? Like if I'll do some uh, apply some techniques, where what could be the sales forecast, right? So even the weather forecast and all, those are also kind of predictive analytics, whether it can, whether it will rain and all, right? So all those things which we see, everything around us, which you see, like, all are kind of a deep learning and machine learning use cases which you see today. You're using email, you can see the spam Gmail is doing automatically for you, right? And so, like, anything, like, even in the Google Photos and all, if you see on your mobile phone, and it automatically categorizes with the face, right? And so in the Facebook, that face tagging and all, right? So all these things are kind of use cases of uh, deep learning and all. Okay, so what is the, like, we know now what is machine learning, right? Machine learning is something which we need to give the data to the machine learning, some algorithm is there, and it will basically, tell you the prediction, right? What can happen that way. So, but there is a pipeline for that, right? There's a multiple things happen, right? Machine need a data, right, to learn by itself. So it requires a data collection, right, where you do the sourcing of the data. You may have to do the ETL, data wrangling. You have to clean the data, massage it, right? So you need to collect the data from multiple source systems to do that, right? And then feature engineering comes into the picture. Like, what we do, basically we do, EDA, that is called exploratory data analysis. You basically do the data preparation, cleaning, normalize the data segregation, right? All those things happen. You identify the features which is right for your model, and then accordingly you go to the for the model training, right? So you train the model. Once model is ready, you do the evaluation to check whether how the model is performing, whether it's, what is the accuracy of the model. Is it performing 80%, 70%, 60%, right? Or can we just improve it? All those things you take it here. And once you are happy, your user is happy, like your business is happy with the performance, okay, we can just go ahead and deploy the model into the production. And then you have to monitor also, okay? So that's one thing which people monitor, it's very important. Once we deploy the model, we have to monitor it also. That is called ML ops. That becomes, altogether a new topic, uh, because your model should have the feedback also, right? And now, what are the types of machine learnings, right? So broadly, we can classify into three: supervised learning, unsupervised learning, and reinforcement learning, right? So what is supervised machine learning? Basically, what it requires is, basically it takes input variable, right? Inputs, basically, right? We raw inputs we give it. By the way, in machine learning, when you say, like, in input variables, we depict it as X. It's not necessary, but this is how the standard way, right? If you're talking with any data scientist or data science, they will say, like, input variable X and output variable is Y. Output variable is also called as a label or target, right? And so when you give the input, like raw inputs, let's say this, you give the multiple types of multiple shapes of apples to the machine, right, to the algorithm. And then algorithm basically, read everything and, understand that, and, and learned it. Once it is learning it, basically your model is ready, okay? Once your model is ready, then you don't have to train again and again, right? Once your model is trained, and then you can give the input to the model, and then your model should be able to tell what it is, right? So then, if your model is able to tell, oh, it is apple, right? So this is what the supervised machine learning. So in case of supervised machine learning, it requires in data, input variable and output variable, right? So let's take another example which will make it more clear. So let's say you have a, some predefined set of characters here, a duck, and others are not a duck. Okay. So duck, duck, not a duck, duck, not a duck, not a duck, right? So you give it to the supervised learning algorithm, right? And ask to do the prediction. Okay. You consider that you train the model, everything is done here. You do all those things here. Okay. And once your model is learned, you have this model ready. Now you give this particular new input, right? New duck input to the model, and the model should be able to tell whether it is a duck or not, right? So it is saying that it is a duck. If it is not, it will say cross, right? It's not a duck. So you see that it is basically labeling that, okay, whether it is a duck or not a duck, right? So that's where supervised machine learning, use cases, is something helpful. Like a spam, when you identify the email whether it is a spam or ham, right? Or identifying whether the person is having a cancer or no cancer, whether the customer will churn or not churn, right? It's not only just two categories, it can be a multiple categories also, right? Whether it is a dog, or it is a cat, or it is a horse, you can have multiple, you can give that multiple input animals as input. It can tell basically what it is, right? It is animal, or it is a human, or it is a fish, it can do. So it's basically doing the labeling. Apart from this, supervised machine learning is also having a regression algorithm. What we talked about, this is a classification algorithm. Inside supervised machine learning, you have classification problem. So this is a classification problem. Then you have a regression problem. Regression is something predicting the sales, right? What would be my sale next week, right? So that's something, you're predicting something, that's a new, that will always be a numerical thing which you are going to predict it. So that's a regression problem. Okay. And like predicting the diamond price, right? Like or predicting the house price, those things, right? So those things you basically consider them as a regression problem. Now this is another type of machine learning which we said is a unsupervised machine learning. Okay. Here you don't have to do the labeling here, right? Here it is something, you don't know what, you have been given the data, right? And you don't know how, what to, like, and it is being asked you to come up with a new patterns of the data, pattern from the data, right? So like you have been given all the characters here, right? Different types of characters. And your unsupervised machine learning, when you use it, it should be able to uh, categorize, come up with multiple categories, right? So all ducks are in one place, right? So similarly other characters are in different category, right? So unsupervised machine learning is very powerful. Okay. Like if from your industry, if you want to find out the segments of customer, right, to whom you should target for uh, for doing the advertisement, right? Like if I have millions of customer, and if I just like if I just decide to do the advertisement and do the marketing for or send up some sort of offer to all the customers, it could be a loss to company, right? It's so much of money which you're putting at stake, and even you don't know whether all the it is relevant to all the customer or not, right? So identifying, creating your market, coming up with a segment of the customers to whom basically you can target. Like Tata came up with the Nano, but so what kind of customer can buy a Nano car? I don't think everyone would would prefer to buy that. But there is some particular segment which can be targeted, right, for doing the advertisement, and for the common people who would like to have buy that car. That is just an example, right? So this is how you find the segment of the customer and you target to that customer only, right? So company basic, that's kind of a personalization thing, right? Today it came as a personalization, which we talked about the telecom industry use case, right? Like you sometimes you will get the offer from the telephone company that, okay, we are giving so and so GB free of the data to you. But at the same time, if you will check your friend from the same telecom subscription, he may not have received that, right? So that's called a personalization, right? Like maybe something they identified that you could leave, right? So they are trying to retain you. So that's called the personalization. So now industry is moving towards that, right? Rather than just broadcasting it to all the customers, they could do basically personalization to the customer. Okay, coming back to here, like data science method. So any data science use case which comes, right? This is what the cycle we follow, right? This is also called as a crisp DM. Okay, so you formulate a question, like you first start with the business understanding of the problem, then you do that, you take analytical approach on that, then you basically analyzing the data and all, then you identify that, okay, oh, we need to, so and so data. So then you basically reach out to the source systems, right? You gather the data from there, you do the data collection, you understand the data. It can be a to and fro problem. You maybe say you need to identify if any data is missing, you need to fix that data. If any data something, you need a new label to solve that particular problem, and data is missing, so you may again want to go back and that's something called the gather data overall process of that, right? And then you do the data preparation and all. Okay, once you do the data preparation, you identify the features which is important to create the model, then you go on creating the model. Once your model is done, you do the evaluation. If everything is fine, happy, then you go for the deployment, and then there should be a feedback. Sometimes what happens, this is very important step which people miss on, like this feedback part should be there, which can go and tell the model, hey, you did a wrong prediction here, you need to fix that, right? So that way you are sending the feedback to the model. Maybe it was apple but you said orange, right? So that's something should be part of the process, right? So this is overall flow. Don't worry about like if you attend, we will cover them in very detail in the training perspective. And ML in different sectors of business, like I definitely I covered many multiple use cases, but just to give you glance, right? It is used, as I said, data science is not limited to particular industry. It is something which is everywhere. Every industry have to use it. It's a basic necessity today, right? Be it agriculture, automotive, you know consumer, energy, be it any industry, right? It is a basic need today. Okay, and now, okay, let's take one use case for the churning customer. Okay, I'll quickly show you it when we have time. Okay, so I'll quickly take you, one of the use case of the telecom industry, right? And by the way, this is called Jupyter Notebook. If some of you don't know about it, this is called Jupyter Notebook, where you can write your code and interactively you basically, write it and run the code, right? So interactively you can do that, right? This is what the Python allows you to do that. Okay, so like here you can, when I say interactive, this is something which you are running and you're able to see, output below. Okay, so this is what the interactive, how the Python is so interactive. In Jupyter Notebook you can do that. And important thing, you can also do that, you can take the notes also, right? You can basically write notes. In fact, you can basically club the images here, that we will just show you, that we'll teach you that also. And so let's take one use case for the telecom industry. So so I'll quickly go here, and don't worry about the like if you do not understand, but idea is to show you how it looks like, what are the steps to follow and all. So let me quickly show you the data. So this is the data which we have it. Okay, so let's assume that some source system has given the data: customer ID, gender, senior citizen, and partner, dependents, tenure, phone service, multiple lines. So these are all uh, features or variables, right, which uh, or fields, whatever you call, right, in your data. And it is saying like, okay, so customer ID is basically a unique ID of each customer, right? Gender of a person, whether it's a male, female, right? And senior citizen, whether the customer is senior citizen or not, right? And so person is married or not, right? Dependent, or he's having children, or retired person, and what kind of services customer is using, right? And so that is what it is telling, streaming, and whether the customer is doing the streaming, movie streaming option is available, what kind of contract it is there, it is a monthly contract, or uh, yearly contract, or customer prefers to have a paperless billing, right? What are the payment method he uses, what is the monthly charges paid by the customer every month, and total charges, and churn. This churn is basically telling you whether the customer has churned or not, right? So this is the this is the metadata which is available, and this is the customer data which is being provided to us in one file, right? So which has a customer ID, gender, senior citizen, partner, dependent, right? There is another file which is given to you, which is having a churn data, right? It is telling you basically whether the customer is churned or not, right? And so that's what it is basically telling you, okay? And what are the monthly charges and all for that, right? And so here you have the internet related data, right? Whether what all services customer is using and all. Okay. Now coming back here, so now what we need to do is mainly basically you have the multiple steps which we seen that, right? You will first importing the data and merging the data into Python, right? And you will basically we will do the inspection of that data frame data. You will play with the data. You will do the data preparation, right? You will do the feature scaling and all. You will find the correlations and all, right? You will build the model, right? And and then some feature selection techniques and all we use it, right? And then you go on for doing the optimization of the problem. Okay, so this is all what we do actually, right? And this is what essentially it is doing here. So this is importing the data, and this is how it looks like. What data, whatever we have seen it in the file, it is showing that. Then you have this customer data, then you import the internet data, and then you're basically doing the inspection of the data frame, is everything looks okay or not. So you see that whatever data which you have taken, you're basically joining the data right here, and you're putting it into one data frame, right? So data frame is nothing but you can just see that like if you see it is just looking like a excel or maybe database table, right? And once you get it, then you basically play with that. You basically describe the data, see how much count is there, mean, median, right? You can check those things. You can find like if any kind of data is missing. Then machine learning usually requires it to be converted into the numerical, like yes and one or zero form, right? So you basically you convert that into that, like we call it one hot encoding uh, technique. Okay, so once you do that, you basically preparing the data, right? And always remember that you don't need each and every field basically, right, for doing the machine learning. So it is very important to identify the right features for the data. So once you identify the right features of the data, so you need to there are multiple techniques to do that. You recursive feature elimination, which we use it, right? You do the correlations and all, right? You check for the any outliers in the data, right? So you basically get rid of some sometimes you do the imputation uh, of the data, or sometimes you basically get rid of missing data if it is a lot, right? So we will also tell you the technique how to do that in that kind of situation. Then how you basically split the data for the train and testing, right? And how you do the feature selections and all. And then how you basically build the model, right? We'll also show you, like, tell you, like, how you can basically read such tables to see what all fields are important, relevant, what is p-value and all, right? So you will learn all those things. We cover that in very detail. And then you identify this, you do the feature elimination, you do the multiple rounds of the data. And you see here there is a customer ID here, and we are saying that churn probability for the customer is 0.19. That is 19% probability is there this particular customer will leave. So this, there is a 27% probability that customer will leave, 60% probability customer will leave, right? So this is what the probability which we come up with, and then we decide, like, should we say, if if it is beyond 4.5, should we say that customer is churned or not churned? And even there is a technique to identify whether 0.5 should be used, or what is the most optimized technique for that, right? So that is where, like, then this we also get into, this finding the optimal cutoff point, right? And you identify that, okay, which is uh, best point here, right? So maybe this point 0.3 is the best, 30% is the most optimum point to do the cutoff. So this is what the, like, how you identify that, and you basically, do the hyperparameter tuning for the model. And this is how the model, finally you get the accuracy of around, and 84% and on. So this is kind of a use case, one of the, for the model. And now just quickly to, to brief you through what is, deep learning all about. So as we discussed, deep learning is all about, like, how we can mimic the human brain, right? That's what the artificial intelligence is. So just to quickly show you, like, this is how the, in human brain, like in our body basically, like, there a lot of neurons are there, right? And how the basically, they interact with each other. So this one neuron, this is another neuron, okay? And these are dendrites basically. And this is axon. Dendrites will basically, depending on the task which we do, like we are doing the brushing, we are doing the breakfast, we're picking up the glass and all, depending on that, it basically sends a signal via axon. And this is called axon. So this basically, sends a signal to the other neuron. And other neuron basically, then accordingly it will trigger the other neurons, right? So now this is, so this is the biological, right? And then this is, this is the artificial neuron, okay? Like if we compare with the biological, so this is the biological. So basically deep learning is, inspired with this biological neurons, how the human uh, uh, brain works. Similarly, the neuron, the structure for the artificial neuron, we have it. So it has basically inputs, like you just consider this is one neuron, okay? But there could be many neurons here, okay? So input variables are there, and this can be a multiple deep layers actually, right? You can have the hidden, like input, you can have weights, basically you give it to the neuron, like, okay, this is the x1, x2, x3, these are nothing but features, right? Which we seen that variables which you give it input to the neuron, but you also give the weights to that, okay? We don't give it basically, right? It is it's so intelligent that it will basically, automatically adjust the weight in every run, okay? Iteration, when we run the model, it basically, like, and then it runs automatically, okay? This is a kind of a black box, right? Algorithm, okay? And so at the broader level, it has an integration function and it has a activation function, right? So it basically does the, aggregating the input signals and all, and depending on that, it is giving the output. So if you given the input like apple, orange, it will basically tell you whether it is apple or orange, right? So that is something which is, possible with the artificial, neurons. This is what the basically, deep learning uses it. And then deep learning is having, multiple types of use case, algorithms. which is called CNN, convolution neural network, artificial neural network, and then you also have uh, to solving other deep learning use cases. So there are multiple types of algorithms also available. So deep learning is everywhere, right? It is a internet and cloud where, like wherever you see like image classification, speech recognition, language translation, language processing, sentimental analysis, recommendation, right? Medicines and biological like drug discovery and all, right? And even like this autonomous car, which we do, right? That is also a use case of deep learning. You do the face detection and all, right? All those are basically a deep learning uh, use cases, right? So we see deep learning each and every places, right? Okay, with that, actually, I'm almost at the end of the course, and so okay, so I see one question was there, like okay, got it. It is a classification problem, so you got the answer, good. And so okay, so what is the benefit of doing the e-learning, right? Advantages. So basically, you get the recorded sessions where you can always go back, and if you miss sometimes you can always, and you can always refer it back, right? Which is available in your LMS for the future reference also. And good part is like we also provide all this notebook thing which I just shown you. Reference materials will be uploaded. So those codes which you can use in your, if you're working on the data science, you can reuse those use cases at your work, or for doing other use cases, you can it will be helpful to do that. So it does the tracking and reporting features. So participants attendance monitoring, which basically at least keep you push that for doing the learning and all. So yeah, so that's pretty much like a lot of advantages for doing this e-learning courses. I think we are good with the session. Thank you so much, everyone, for joining the session.